Gyroscopic instruments. The gyroscopic instruments include the attitude indicator, the heading indicator, and the turn coordinator. These are considered gyroscopic instruments because each one relies upon a gyroscope to function. They can either be driven by air suction or electricity. These instruments provide the pilot with such things as their pitch, bank, yaw, and heading. Before we get into each instrument, let's talk about what a gyroscope or gyro is and how it works. In its simplest form, a gyro is a heavily weighted spinning disc that is able to maintain its position and orientation. Gyros operate based on two principles: rigidity in space and precession. Rigidity in space refers to a gyro's ability to remain in a fixed position in the plane in which it is spinning. By mounting the gyroscope on a set of gimbal rings, the gyro is able to rotate freely in any direction. Thus, if the gimbal ring rotates, the spinning gyro will remain in the same plane in which it was originally spinning. The other property of the gyro is known as precession. Precession is the tilting or turning of a gyro in response to a force. For instance, a small force is applied to the gyro whenever the airplane changes direction. However, instead of the gyro responding at the source of the force, as expected, the result will instead occur 90 degrees ahead of that point in the direction of rotation. What this means to you is that sometimes the instruments may have some unwanted errors, such as a slow drifting and minor erroneous indications in the instruments. The good news is that all gyroscopic instruments have ways to either automatically or manually correct for this precession error. In order for gyroscopic instruments to work, the gyros have to spin at a very high speed. As previously stated, the instruments can either be powered by air or electricity. For safety reasons, different instruments are powered by different sources so that if one source fails, the other source will still work. The attitude and heading indicators are typically powered by air, and the turn coordinator powered by electricity. The spinning of the gyros with air is accomplished not by blowing, but sucking air around it. A vacuum pump connected to and powered by the engine draws filtered air from the cabin through the instruments, spinning the gyros, and then dumps out the air into the engine compartment. Let's look at some of the different instruments that use gyros. Attitude indicator. An attitude indicator is an instrument used to inform the pilot of the orientation or attitude of the aircraft relative to Earth. It indicates pitch, which is the fore and aft tilt, and bank or roll, which is the side-to-side tilt. Through the use of an artificial horizon and miniature airplane, the instrument depicts the position of the airplane in relation to the true horizon. This is especially useful when the natural horizon is obscured by clouds, the visibility is poor, or when flying at night. Along the outer rim are tick marks to indicate bank at the 0, 10, 20, 30, 60, and 90 degrees angles of bank. Degrees of pitch are located both above and below the artificial horizon in either 5 or 10 degree increments. At the top of the instrument is a small triangle that points to the correct bank angle the plane is in. The center of the miniature airplane lines up with the current pitch the plane is in. The gyro in this instrument spins around the vertical axis, meaning that the gyro rotates level with the horizon. The two gimbals holding the gyro allow the gyro to move freely and maintain its level orientation as the airplane maneuvers. Connections to the instrument face will then show the aircraft's attitude to the pilot. Note that if the airplane is experiencing an excessive pitch or bank, or if vacuum pump is not providing enough suction to spin the gyro, this instrument can read inaccurately. Heading indicator. The heading indicator senses the airplane's movement and displays heading based on a 360-degree azimuth in 5-degree increments. The tick marks are labeled every 30 degrees, with the final 0 omitted. For example, the number 6 indicates a heading of 60 degrees. 21 indicates a heading of 210 degrees. The heading indicator does not have any built-in heading sensing ability, so at the start of every flight, after the engine is running, the pilot must realign the instrument to correct heading, referencing the aircraft's magnetic compass. To accomplish this, push in the knob on the lower left side of the instrument. This both disconnects the gyro from the compass card and aligns the gear of the knob with the gears connected to the compass card. When complete, release the knob and the gyro will reconnect to the compass card. Unlike the attitude indicator, the heading indicator is orientated so that only the horizontal axis is used to drive the display. When the aircraft turns, the gyro and attached main drive gear remain in their original orientation. This then causes the main drive gear to rotate the compass card gear, which then rotates the compass card on the face of the instrument. Note that, due to friction and precession, The heading indicator may slowly drift away from the correct heading. Because of this, the pilot should double-check the accuracy of the instrument against the magnetic compass and realign as necessary. This should be done roughly every 15 minutes or so. Keep in mind, if the vacuum pump is not producing sufficient suction, when the engine is idling, the drift may be greater. Turn coordinator. The turn coordinator is a supporting instrument used while banking. It is used both to indicate the rate and quality of the turn. It can also be used as a backup source of bank information in the event the attitude indicator fails. In the center of the face of the instrument lies a miniature airplane that indicates the rate of turn the aircraft is currently in. 2 tick marks indicate level. The other 2 tick marks indicate what is called a standard rate turn. A standard rate turn is one that takes 2 minutes to complete a 360-degree full circle. This is the rate that all pilots fly when in instrument meteorological conditions, meaning they have no outside references to follow. Below the miniature aircraft is an inclinometer, which incorporates a ball inside a tube filled with kerosene. The ball can freely move left and right and will travel in whatever direction aerodynamic forces push and pull it. Ideally, the ball should always be centered, which means the aircraft is coordinated. If aerodynamic forces are unbalanced, the ball will slide left or right. This happens when there is either too much or too little rudder being used with the current amount of bank. These 2 conditions are referred to as a slip and a skid. In a slip, there is not a great enough rate of turn for the amount of bank. The pilot needs to add more rudder and/or reduce the bank. In a skid, there is too much of a rate of turn for the amount of bank. The pilot needs to add more bank and/or reduce the amount of rudder. The easiest way to remember how to fix these situations is just to step on the ball. This means that when the ball is deflected off center, step on the respective rudder pedal that the ball is deflected toward. A ball deflected left means step on the left rudder. Conversely, a ball deflected right means step on the right rudder. To get this instrument to function, it is typically powered by electricity. For this instrument, the gyro rotates from a motor located in its center. The gyro is mounted so it can remain upright while in a turn. Mechanical linkages then connect the gyro to the miniature airplane on the front of the instrument. A spring is installed to help return the mini airplane back to level. Because of this, the pilot would never know if the instrument has failed. So, if the instrument is not receiving electrical power, a red flag will be visible on the face of the instrument. Another important aspect to notice on the inside of the instrument is that the gimbal holding the gyro is not level. In fact, it's actually rotated 30 degrees. Unlike its older cousin, the turn and slip indicator, this change allows the instrument to also measure the rate of roll as you enter the turn.